Hey guys, welcome back to our channel. So I apologize for the lack of videos being posted, but I've been quite busy doing research with my research, so I haven't really had much time to do the videos, but I'll pick it up, I promise. Um, so in this chapter, or I mean in this video, we're going to talk about work, what it is and what it looks like. So from your textbook, you're most likely going to know that it's d uh, times the force, right? Force times distance will give you work, but many times this comes out as force times d times the cosine of theta. And that's one of the reasons, the reason why this is true is because it's force parallel to the distance traveled. And many times the force is at an angle, so then it turns out most of the time it's cosine. And you guys don't need to know if it's a cross product or a dot product, not in non-calculus physics. So now what this looks like, and I'm going to give you guys some examples. What that looks like is, so for example, you have a surface, right? Let's see. You have a surface and then you have a block right here. Right, let's say it's a 10 kilogram block. And then there's a force being applied on it, a string pulling it with 50 newtons. The tension is 50 newtons, the force, same thing, right? And it moves at a distance of 10 meters. So now the problem asks you, what's the force? Well, work equals force parallel to the distance, right? And there's no angle here because the force being applied is parallel to the distance being traveled, right? So that means it's just going to be, what's the force? So many people make the mistake here of saying, oh, okay, the force is just, force of gravity going down, and it's just mg. It's actually wrong because it's the force being applied on the direction of movement. All right, so with that being said, it's going to be 50 newtons times your distance, which is just 10 meters. So that's going to be 500 Newton meter, which we know as joules. All right, so now you say, okay, cool. What about if I have, have that being pulled at an angle? So in that case, let's see, right here, and you have a box. I think I'm going to start using the figures more often just so, you can see it better. It makes more sense maybe. Have the box, right? And now there is a force pulling it at an angle. Pulling it, right? And it's pulling it at an angle with the surface of 30 degrees, right? So force is right there. Same force that we used previously, 50 newtons. The box is the same, 10 kilograms, right? And then again, it moves at a distance of 10 meters, right? So now, again, we're just going to plug in formulas. Now, work, we said, is equals to the force being applied on the object parallel to the moving distance. So this makes a 30-degree angle with the surface. So remember, from vectors, we can break this down, and this turns out to be 50 cosine 30 degrees. And that's where this comes from, right? The cosine angle, because it's a vector breakdown. So now this turns out to be 50 newtons times your cosine 30 degrees, right? Times your distance traveled, which is 10 meters, right? So now you put that in the calculator and you end up having 433 joules. All right, so now you did a lot less work over the x-axis because you were also doing some work over the y-axis, and that would have been 50 sine 30 degrees, right? So you were actually wasting energy as you were pulling it up because you were trying to move it two directional. So that's all I have for you guys in this video. I hope that it was helpful. Remember to Let us know in the comments if you have any questions, you want further clarification, some help with a specific problem. Remember to like us on Facebook, subscribe on YouTube, and in the next problem, I think I'll keep it up with work, or I might pick up some other subject. So good job, guys. Keep up the study.